Hey, hi, what's up? It's Sid here, and this is the third video in my AI Basics with C++ in UE4 series. So I had conducted a survey or a poll asking you devs what you wanted in my next video. And the options were creating a patrol slash chase bot, adding waypoints for the AI randomly in the level, and making the bot halt at waypoints more often. So a lot of people said they wanted the patrol slash chase bot. So that's what I'll be doing today. And I'll be covering the other two in a future set of videos. All right. So thank you for your response and let's begin. All right, so let's continue where we left off from last week's video. So in last week's video, if you've seen it, then we ended up creating a simple waypoint based bot that ran from waypoint to waypoint, like so, and totally ignores the player when it passes by him. Okay, I can just stand here and the bot will not even bother chasing me. Blah blah. Right, so we will try changing that today. Uh, so as we will be making a patrol slash chase bot. In this case, the bot will move from waypoint to waypoint as long as it does not spot the player, and the moment it spots the player, it'll start chasing the player, ignoring all waypoints along the way. Okay, so if I start with gameplay debugger, right, I remove all those lines. All right, so it's being detected, the player is being detected, but the bot is not chasing him. Right, so let's begin. Now, before we start programming, I think it's good to have a small understanding of what we are exactly doing, or just a brief overlook of that. Also, yeah, before I forget, don't like start off with this video unless you've checked out the first two videos of the series, because in the first video I'm setting the base for the bot, and in the second video I start by creating a bot that moves from waypoint to waypoint. This video is basically the conclusion of those three videos. Sorry, of those previous two videos, and builds upon them. So most likely, if you're just starting out with AI right now, you won't get a lot. And again, this project that I've currently got open here is nothing but the same project that I had finished last week in last week's video. So okay, now, before I proceed again, just open up Paint and I'll just give a small description of how we will proceed with it. Now, consider if you remember from last week's video, or sorry, from the first video actually, where we set the AI perception component. I've gone in detail over there, but I'll still like just walk you through the basics. There's these variables here, sight radius and field of view. These two are going to play a very vital role in uh, dictating basically, how far the bot can see, and what is the peripheral vision of what is the field of view of the bot. Okay, so that being said, if, for example, if I were to say, consider this little thingy bot, and this would be the perception component's radius around it. So anything inside this is detected by the bot. Anything outside it is basically invisible to the bot. So if my player is out here, then the bot keeps moving from waypoint to waypoint. However, if my bot comes in here, then I'm sorry, it's my player. If my player is out here, then the bot keeps running from waypoint to waypoint. Whereas if my player comes in here, like if it's inside the radius, then the bot starts chasing it and ignores the waypoint. Also, the it's better if we denote the bot like this, since that uh, red. Okay, So let me just turn that back again. Now, if I were to say that the red region, okay, so if I were to say that this is the front direction that the bot will always be facing in, then this will essentially be the region that the bot cannot see in. So a 90, if you consider this value here, AI field of view, be 90. That means that the bot can only see in this much region. So even if my player were to come in this region, the red region, but my bot cannot see behind his back, basically. So the player would be invisible to the bot. All right. That being said, this blue region is really all that the bot can see in front of it. So yeah, now how we will proceed ahead with this? Mainly, we will keep track of two things. One, so I'll represent the player, say with an orange here. So now, if my player is out here, it's safe to assume that the distance between the bot's center and the player's center, like so, is greater than the radius of my perception component. So my perception component is here and my radius extends out here. The player is safe. And we keep track of this, of course, so that we can switch states from moving to a waypoint to moving to a player chase kind of state. Okay. So once the player comes inside here, like this, then the distance between these two lesser than the radius of the perception component, and the bot abandons its path to the waypoint and starts chasing the player. So that's pretty much how we will be proceeding ahead with this. Now let's begin programming the thing. It's fairly simple. I'm not going to be going into any complicated uh, things for now, at least. We will look at optimizing the bot and also making it more fun in subsequent videos. So anyway, let's come to the AI bot controller.h file. In here, you will need to declare two variables. First one needs to be, and of course, the first one is going to be a bull variable, and that's going to be bull b. Okay, I'll just write it down. So let's make it visible anywhere. So it is visible in the blueprint as well. And let's name this b is there detected. And let's set it initially to false. Right. Next one we need is the distance variable. Now the distance basically is this. Helps keep track of how far or how close the bot is to the player. All right. So let's make this a float. Float distance to player, and let's give this an initial value of 0. Okay. So I think that pretty much .h file, and let's move to the controller PPP file now. In here, we'll need to set in a couple of header files before proceeding. So the first one is uh, something called gameplay statics class. We'll need the gameplay statics class for accessing the player. Now, I'll show you what that does a little bit later, but just for now, add it as it is. Hash include time engine hash yes, hash game dot a, and the next one is the header file for the bot character. This one, which is the player basically, right? So bot character h. All right, so we've got our header files in place. Next, the bulk of programming is gonna be in these two functions. take function and the onPawn detected function. Now, if you remember from the first video, onPawn detected is a function that is like an event handler basically. It's over here. So this function is run every time. It's run every time either when a player enters the field of view here or it exits the field. Now, there's a little quirky thing with this function, the onPawn detected function, or whatever you choose to name it. And it is that if the bot, like if you think about it logically, you would want the array over here actually contain one character or contain a character when it enters and not contain it or like delete it or push it out or pop it out, sorry, when it exits, right? But from what I've seen so far, the detected pawns, the array over here, it never quite hits zero. So I'll just give like a quick walkthrough of what I mean. So if I were to do this, if detected pawns dot num, and this won't take too long because like a small thing, but it's important to keep in mind when you're working with the perception component in UE4. Warning text should be bought as enter field of file. I'm sorry, player has entered. Okay, and the else part. Let's copy this over, copy over, paste it down here. Player has exit. Okay, so ideally this function should run every time the bot enters or exits. And just to show you what happens, I'll compile this. Also, yeah, I'll just disable the waypoint movement so we can actually test out how the onPawn detected works. I'll just give this a quick compile and I'll see you in a bit. Okay, so let's play. And the bot's pretty static or like immobile. Let me press G on the activate the gameplay debugger, and there you can see that everything is working fine as it should be. Now, if I enter, you notice that in the output log, player has entered FOV runs once, which corresponds to this. So, okay, the number of actors in the detected pawns array has increased, but is greater than 0, so safe to assume it is 1. Now, if I am to exit this again, I get player has entered FOV. But shouldn't it have written player has exited it? So yeah, that's pretty much the quirky part. Whether you enter or you exit, eh, the array never quite gets cleared. So yeah, like the bot's blind spot, I am well within the radius of the perception component, but the bot cannot see me. However, if I enter here, it does see me and it tracks me, right? So that was the problem I wanted to highlight. That's why for that we have I kind of came up with a slight workaround. It's not too complex, but it does get the job done pretty well. So okay, now let me go back here and let me open up Visual Studio. All right, let me clear this from the on detected function and let me come up here. Okay, so we finished up with our controller over here, the .h file, and now we can start by working on the .cpp. So in the function down here, onPawn detected, let's first run through all the elements in the detected pawns array. Okay, and let's get the distance between the player and the bot at the instant the player enters the field of view of the bot. So what that would be like is this. the moment the moment the player enters the bot's field of vision, the distance is set, right? So yeah, then a variable for that was distance to sorry distance player is equal to, let's get the pawn on the of the bot first. Get pawn, call the distance to, or get distance to, get, yeah, okay, fine. To the other actor, which happens to be the player bot. Okay, which gives us the distance. Yeah, and let's just log it for checking. So log temp, uh, thing and x float. Make sure that it's small f, distance f, pass in variable. Now come down here. So basically, once the distance is set, it's safe to assume that uh, the player is within the field of vision of the bot. So in that case, all we need to do is, sorry, it was p is player detected is equal to true. Okay. Now let's get to the take function, and I'll uncomment this the waypoint movement code. I'll set an else part down here. Else if b is player detected equal to true. Okay. Then what I want to do is I want my bot to play. So I will do that using a cast. I'm not sure it's really essential, but in case in the future I plan to use the bot bot's reference in the take function, I would rather have it casted than have an actor reference directly. So sorry, a character reference. In that case, a bot and character here pointer. Sorry, so here is equal to uh, class a bot character. Now this is where the uGameplay statics class comes into action. So uGameplay statics basically contains a whole bunch of useful functions that help you access players, characters. Sorry, the player's character, its controller ID, yeah, the player's pawn, etc. Yeah, it's one of those functions you really need every now and then. So get world function again, and player's index is 0. Okay, and then I'll move player at the distance f. Now we are missing one more small bit here, and that is if you see this here, once you enter, b is player detected is always set to true. So even if the bot exits the field of view somehow, I'm sorry, even if the player exits the bot's field of view somehow, uh, b as player detected will always be true. So even if your bot can't see the player, it'll keep chasing the player. So we need to make slight a small change up here, and that is if your distance to player greater the AI's sight radius. Okay, so basically, if the player is outside here, that is, if the distance between the bot and the player is greater than the sight radius, then in that case, P is player detected is equal to false, and that should pretty much do it, I guess. So I'll just give this file again, and hopefully it should all work out just fine. So I'll just see you in a bit. So there was a slight problem that I kind of overlooked before starting the compile, and I just noticed now. In here, in the move to waypoint section condition, you need to add B is player detected to also false. Like you want the you want the bot to chase the player when he is detected, okay, and you want the bot move from waypoint when he is not detected, when the player is not detected. These two conditions are really crucial. Otherwise, everything is fine. So just make sure you add this away, and you should be good to go. Now coming back here, this is our bot. This is our player not playing, and as you can see, I'm way out of the AI bot's field of view right now. So I'll just press G to confirm that. Okay, there it is. So there it's moving, and that's detected me, and now it's running right behind me. Okay, and there it's lost me. Now it's going back to the waypoint it was supposed to go to originally, and it keeps on doing that again. It takes me, alright, and it loses sight of me, and it goes back to the waypoint. So pretty cool, I should say, if you're like just starting out with AI. And yeah, so that pretty much concludes today's video, I guess. Don't forget to smash that like button if you really enjoyed this, if you learned something new. Let me know what you think about this video down in the comments section. Any requests for new tutorials or anything. As usual, I will be posting a link to all the source code for this on my GitHub account. A link of that will be posted in the description below. Uh, yeah, and don't forget to subscribe. Thank you, and have a good day.